Hello everybody, welcome to another part of the OpenThread 101 series, and in this video I will introduce you to OpenThread CLI. OpenThread CLI is a tool from OpenThread, and here in this video what we would do is we would just create a basic thread network using OpenThread CLI. This network would contain two NRF 52840 devices. We would configure the network, and we will then ping one device from another one, and will show you that the network has been formed and that it is working. So what is OpenThread CLI? It's a program that is being developed by OpenThread. The source code you can find here in this link. The main purpose of this tool is to provide an easier way for people to play with OpenThread, and it's very useful for beginners because then you can basically focus on the OpenThread part, and you don't have to worry about writing your own source code, and you can just basically use some simple command line tools, some commands, and to create networks and do different stuff with it. It can also be used to run different tests in development, and also just to run different tests before production to ensure that your devices are working as expected. And just to be noted that it is not intended for production use, but it's a useful tool to get started. Now what we would do is we would just open the OpenThread CLI reference document. So it's the GitHub repository. So if we go there, basically this is the source code for OpenThread CLI, but the README file is really useful here. And here you have the list of all the commands that it supports. So you can see that it even has some commands for coap. There is a command for ping that we will use in this case in this tutorial, and there are TCP command, and there is even a UDP command that allows you to send UDP packets, and the different stuff. So we would come back here again. So just for now we would just get started with flashing our devices with the OpenThread CLI. So we just open Visual Studio Code, and if you have followed along, then you would have your development environment ready. So what we would do is we would start with creating a new application. We would start with the sample, and in the sample we would select the OpenThread CLI sample. So we would select it. The default path is okay for us, so we would just open this project. Now, just like the last time, we would add a build configuration, and would select our board, which is NRF 52840DK, and then /NRF 52840. We select our board and we click build configuration. Now it will build the application for us. Okay, so the application has been built. In this case, we don't have to look at the source code, but there would be some boilerplate here, some optional settings, some optional features that you can enable, disable, but we don't want to look there at the moment. What we want is now, once the application has been built, we want basically start flashing it. And if you look at the connected devices, I have two NRF 52840 boards connected. I have renamed them into device 1 and device 2, so that it's easier for me to know which device I am on. So we would use 2 devices in this tutorial. So let's flash them. So first I will flash device 1. I would do is flash and erase so that it doesn't have any leftovers from the previous installations. So now the device is being flashed. Okay, so the device 1 has been flashed. Let's connect to the UART of this device and see what if it's correctly working. So you already see a star here, so it looks like it's working. Currently I don't type anything, but if I type enter, it will print the UART and then the $sign. So that means that we have a command line interface active on the UART, and basically this device 1 is ready. Before doing anything with it, let's also flash the device 2 and open the UART for that as well. So we would flash device 2 as well now. Okay, so device 2 has been flashed as well. We can connect to the serial port for device 2 as well. So the 2 devices I have are from a bit different revisions. So one of them seems to have 2 ports, but I know that the VCOM 0 is the one with the UART. I don't know what this other one is used for. So I will just connect with the UART for this device as well. And if I type enter, then or if I enter, then I would see the UART for this device as well. If I type help on this device, it will give me a list of possible commands. So what we have here is basically a command line interface from Zephyr, and you can then enable different tools or different options or different commands in these CLI command line interface. And what we have here is basically the OT command is enabled, which adds support for OpenThread. So what we would have is, if we want to use the OpenThread commands or the commands from the OT CLI, we would have to use them like this. So OT, and then when we do help, now the help command is basically the help command from the OpenThread CLI that would get executed. And here now we have the possible commands that are included in the OpenThread CLI, and so that's how we would use it. I would just clear this screen. I would go to the device 1, and here I would just use the commands that would create a network. So first, what I want to do is I would do OT state, which means it will give us the state of our OpenThread interface to see what it's doing. So currently it is disabled. What we would need to do is we would need to set some information in here. We would have to, so that those information can be used for creating the thread network. And those information are called dataset or operational dataset. So if we search OpenThread operational data set, you have from the OpenThread documentation or reference documentation, this is the APIs for operational data set. This is not what we want. We want this one. So basically, this is how you interact with the data set programmatically. But we don't want that. We want to interact with it using the CLI. So with the CLI, you can display the data set and manage it as well. And the data set is basically what you call, like in the Wi-Fi world, it's the name of the Wi-Fi and the password of the Wi-Fi. So here some information that are included in the data set, and yeah, so I will just show you how to set the data set. So what we have, first of all, if we want to see the data set, we would have OT, and then we just type dataset, and it will just print done. So what it means is, usually when a command is successful, it would just print done. And in this case, we wanted to see what dataset we have. So we don't have anything in the dataset. That's why it basically printed empty. In the OpenThreads, you have basically two types of datasets. So the one is basically, you can call it like pending, and the one is active. So the active one is the one which is like currently in use, and the pending one is the copy that you can basically create and edit and update and do different stuff with it. And once you have that dataset ready, then you can just give it a command to activate that one, and then that one would be applied as a new one. There are several parameters in the dataset like you see here. So I guess to make it easier so that people can set these different values, and once they are ready, then they can activate them, and then those would be moved to the active dataset. Before that, it is being kept in the pending dataset. Here you can say pending operational dataset. So the pending operational dataset is used to communicate changes to the active operational dataset before they take effect. The pending operational dataset contains all the parameters from the active. So they are basically same information, just the one is actively being used, and the other one is just something like a work in progress entry for it. So OT CLI makes it easier for us to set these values. Currently, we don't want to do it manually. So what we would do is basically create just some predefined value, just to show you how to see the active dataset. So this one was OT dataset, and this one is to see the pending dataset, and the command to see the active dataset is OT dataset active. And here you see it says error not found because currently there is no active dataset. Somehow they decided to print an error here, and here they decided to print nothing. So what we would do is let's create a pending dataset from some predefined value. So what we would do is the command is OT dataset, then init and new, and I will make it a bit bigger so that you guys can see it. Let's hide this, and let's see if I can make it even more bigger. Okay, so OT dataset init new will basically populate our pending dataset with some values, some predefined values. So let's enter, and now it says that it is done. So if we type the up arrows, it will take us to the previous commands. And now with OT dataset, let's have a look at the pending dataset values. So if you remember last time when we did it, it just printed done and no information. Let's see this time. So this time we have a bunch of information, and these are all the information that are related to our thread network. So we are using channel 14, this is our extended pen ID, this is our mesh local prefix, this is our network key, this is our network name, this is our pen ID, this is our pre-shared key or something. So basically all these information are created for us automatically now. When we want to use our own networks, then these informations would be something like we would already have defined, and some of them we would keep it secret as well. This is basically, you can think of all this information as your Wi-Fi name and password. But just to make it easier, we created them on the fly, and now this is this pending dataset is ready to be activated. In future videos, I will talk about this in more detail, so don't worry about it for now. For now, we just want some predefined default values that would work. Again, if we have a look at our active dataset, it is still giving us an error because we haven't committed our pending dataset yet. So we haven't marked our pending dataset as active. So what we would do is we would, in order to make this pending or temporary dataset into permanent one, or something that would actually be used, the command is OT dataset. So remember, all the commands for the OT CLI needs to be have this OT before, and so we would do OT dataset, and then it's commit and then active, and this would basically make this our active dataset. You can think of these as these are just two, these are stored in two memory locations, and one memory location is for the pending one and one memory location is for the active one, and the system uses the data in the active one. So this would basically copy it. So now it says done. So if we check our active data set now, you see that it is now copied there, and we don't see the not found error anymore. And now what we want to do is basically our information, or the system has all the required information now, and now what we just need to do is to bring up our network interfaces. So for that, what we need is OT ifconfig up, and then the next command that we would need, now the interface is up but the thread network hasn't been started yet, so what we would do is OT thread start, and this command is also done now. So if now we want to check the state of our interface, we would do OT state, and if you remember from before, the OT state was disabled. Now the OT state says here it says leader. So if you remember, in the previous video I told you that the devices, there are different types of devices. So some are nodes, some are routers, and different things, and each network has one leader. So each network, mesh network, has one leader, and the leader is the guy who decides which device has the router role. So if a device is a full thread device, the leader can ask him to serve as a router, or can ask him to stop serving as a router. So leader is responsible for making some decisions on the network level. So since this device is just the one device on this network, it is now a leader. So whenever a device starts, and it has these networking information. It will look for an existing network that has this information. So basically, it will check if there is a network with this name and this channel and this PAN ID. These are basically the information, the name of the network and the PAN ID, or the information that a device needs to join a network, and the network key as well. The name and the PAN ID are basically used to identify a network, and the network key is then the password to join the network. So if a network has the same name but the PAN ID is different, then that is a different network. But here now our device has the leader role on this network because it's the first one. And when this device started, it did not find any network with this, which has this information. So it created that network basically, and it is now serving as a leader for that network. Now what we need is, on the device 2, is to have all that information entered. So we would copy that information from device 1 into device 2 now, and but let's have a look at the state of the device 2. So OT state, it is disabled. We can do so the way we want to copy the information from device 1 to device 2 is basically we would have to either type them manually, or maybe we can try generating it. Maybe if it creates the same information, then maybe it would work. So let's see. So we would issue the command to generate the network parameters. So it says done. Now we want to see it. So let's have a look to see if these information are the same. So the name is 0AA5 here. The name is different here. So basically, these information are not the same. So we can, if we now start the network here, this device would create its own network. So what we need is to copy the information from here. And the way to do this is either we copy the names individually and use the respective commands to set these entries, but there is an easier way to do this. So in order to do the easier way, what we have is on the device 1, what we will do is OT dataset active. So this will show us this dataset, but there is another way to display this information which is easier to copy. So if we type -x to this command, it will print this information in a hexadecimal format. Let's make it a bit smaller so that we can copy it. So now you see we can select it. Before, if I was selecting it, it's leaving this F8 outside. But basically what you have to do is to copy this, and then on this side, so this contains all this information now, this bytecode or hexadecimal string. Now here we would set this information. So what we would do here is OT dataset, and then we would do is set active. So now what we want to do is to set the active dataset to that string. Hopefully it's the correct one, but we will verify it. So what we would do is enter. So now it says done. So let's have a look at OT dataset active. Let's have a look at the active dataset. So here's the active dataset for device 2, and here's the active dataset for device 1. So the name is on the device 1, the name is 0AA5. On the device 2, the active dataset, the name is 0AA5, correct? the PAN ID is 0AA5 again, so basically correct. The PSKC is 63 and F5, 63 F5. Channel 14, yes. Network key is 13D and then 7F at the end. So network key is 13D, 7F at the end. If you know of a quicker way to verify all this information, please let me know. But basically now you can see that both of the devices have the same network information. If your device or the USB cable that you are using is not of good quality, then you might have issues in pasting this much long string. I'm being bitten by this so many times because something gets changed when I paste it, and then it doesn't work. So then I got some good cables, so now it seems to work. So on the device 2 now, since we have already something OT dataset active, so we already have our active dataset now. So what we need is now to just start our network interface. So what you would do is OT config up. It's OT ifconfig up. OT ifconfig up, and then OT thread start, and then we will just check the state. So OT state, so now our device is in the child role. Let's just clear the screen here, make it a bit smaller, and I will clear the screen here as well on the device 1. So here the state is leader, and this one is now being changed to router. So this has the leader decided that this one should be a router. So this one is also a full thread device, so it can serve as a router, and it's up to the leader to decide which device is router and which device is a node. Now if you want to check the IP addresses assigned to this device, so these are the IP addresses assigned to this interface. The command for them is OT-IP address, IPADDR, and if you want to see them with more information, then you can also enter a -v or -v, and that would give you some additional information about these addresses as well. For now, what is important for us is this address. So the one which starts with FE80, and then a bunch of zeros, and then this one. So for device 2, I will copy this address. This address is called link local address, and this is basically a local address like 192.168.1.1 or those kind of addresses. In this case, this one is link local, so it means it is only going to be sent just with the one hop, and so it's only accessible for the devices which are directly in the range of this device. On device 1, we can also look at the IP addresses here. So here, these are the IP addresses. What we want to see now is if we can ping device 2 from device 1. So what we do is OT ping, and then we would paste the IP address of our device 2 and see it once. So it says 16 bytes, 1 packet transmitted, 1 packet received, packet class is 0. So basically the ping worked. And if we want to ping device 1 from device 2, then we can switch to device 2 and do OT ping and paste the IP address of the device 1 and enter, and basically it's working as well. So we can successfully ping these devices from one another. And in the next video, then I will show you how to send a UDP packet from one device to another one. Thank you very much for watching this far, and I hope that you liked it, and please let me know if there is anything that can be improved, and see you next time.